Welcome back, Marauders. This video 8.7, we're going to be looking at exceptions to the octet rule. So we'll be drawing Lewis dot structures, and we'll be seeing some examples where not everything gets 8 valence electrons, not everything gets a full octet. So the exceptions that we're going to be looking at will be with beryllium and boron. They frequently have less than an octet, so those are small atoms, and they can become stable without getting 8. Sometimes they'll get either 4 or 6 valence electrons and become stable. And then the other exception we'll look at is exceeding the octet, and that'll happen with elements in the third period and below on the periodic table. So when you get into the third period, there are d orbitals available, and so you can actually hold more than 8 valence electrons. So elements in the third period and below, so examples would be like silicon, phosphorus, sulfur, and chlorine would be examples. They can exceed the octet. They can only exceed the octet if they are the central atom. And so we'll see that when we start drawing Lewis dot structures, that you'll have to put the extra electrons on the central atom. All right, so let's look at some examples. So the first one is SF4, so sulfur and 4 fluorines. So the first thing we'll do is add up the valence electrons. So we have sulfur, which has 6 valence electrons, and then we have 4 fluorines, which each have 7. So that's a total of 34 electrons. So we'll put the sulfur in the center, right? The thing that's listed first is typically in the center. And then we have single bonds to the 4 fluorines. So with those single bonds, that's 1, 2, 3, 4, 5, 6, 7, 8 electrons. We need to put 34. So we'll continue completing the octets on these fluorines. So that's 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So we've put 32 electrons, and we've given everything an octet. We have, though, 34 electrons total. We need to put those other electrons somewhere. So those 2 extra electrons, they can't go on the fluorine because fluorine is only in the second period of the periodic table, and it's not the central atom. So the 2 extra electrons will go on the sulfur because sulfur is in the third period of the periodic table, and there are d orbitals available. So it can exceed the octet. In this case, sulfur will have a total of 10 valence electrons. BH3, so in this example, we have valence electrons 3 for the boron, and then 3 times 1 for the hydrogens. So that's a total of 6 electrons. So we have the boron, and then we have single bonds to the 3 hydrogens. And with just those 3 single bonds, we've used up all of our valence electrons. We don't have any additional electrons to complete the octet for boron, but that's okay. Boron and beryllium frequently have less than an octet. And so that would be a good Lewis dot structure, even though boron is not getting an octet. ClF3. So we have 7 valence electrons for the chlorine, and then we have 3 times 7 for the fluorines. So that's 28 electrons total. So we've got the chlorine in the center, and then we have single bonds to the 3 fluorines. So that's a total of 1, 2, 3, 4, 5, 6 electrons. We need a total of 28. So 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we've done 24 electrons, but we need to do a total of 28. So the extra electrons will go here, 25, 26, 27, and 28. So this chlorine will have 2 extra pairs of electrons, giving it a total of 10. So the chlorine exceeds the octet. That's okay because it's the central atom, and chlorine is in the third period. ICl4 with a -1 charge. So the iodine is bringing 7 valence electrons. We have 4 chlorines, which each bring 7. And then we have 1 extra because we have a -1 charge. So that's a total of 36 valence electrons that we need to place in this structure. So iodine is in the center, and then we have 4 chlorines attached to it. So that's 1, 2, 3, 4, 5, 6, 7, 8 electrons. We need to place a total of 36. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So that's 32 electrons. We have a total of 36 that we need to place in this structure. Chlorine is in the third period, so it can exceed the octet like we saw over here, but in this case, it's not the central atom. Only the central atom can exceed the octet. So our extra electrons this time are going to need to go on the iodine. So we'll put 2 pairs of extra electrons on the iodine to use all 36 electrons. So iodine exceeds the octet. This is a polyatomic ion, so we're going to put brackets around it and show the -1 charge to show that it has 1 extra electron somewhere in that structure. BeCl2, last example. So beryllium has just 2 valence electrons, and then we have the 2 chlorines, which each brings 7. So that's a total of 16 electrons. So the beryllium is in the center, attached to the 2 chlorines. So that's 1, 2, 3, 4 electrons. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this case, you make a structure where the beryllium only has 4 valence electrons. It doesn't get a complete octet. But remember, boron and beryllium frequently have less than an octet. All right, so those were examples where we're drawing Lewis dot structures with exceptions to the octet rule.